let us learn about congruent triangles. When do we say that triangles are congruent? Firstly, they should have the same shape and then they should have the same size. If we rotate one triangle or translate it or reflect it, the triangles will still remain congruent. Now, what is the difference between congruent triangles and similar triangles? Similar triangles have the same shape, but they don't have the same size. So one of the triangles has to be either scaled up or scaled down for them to become identical in size also. Then they are called congruent triangles. So let us look at these two triangles. They are going to be called congruent triangles if the corresponding sides are equal in length and corresponding angles are equal in measure. So we can say that side AB is equal in measure to side DE. Side BC is equal in measure to side EF, and side AC is equal in measure to side DF. Not only that, angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. So if the corresponding sides are equal in length and the corresponding angles are equal in measure, the triangles are exactly same in shape and size, and they are said to be congruent triangles. Now we are going to learn about the 4 tests which we can use to check whether two given triangles are congruent or not. So first test is SSS test. That means the 3 corresponding sides of the 2 triangles must be equal. So we are looking at these 3 triangles, 2 triangles, ABC and DEF. If I say that angle side AB is equal to side DE, side BC is equal to side EF, side AC is equal to side DF. So if the 3 sides are equal to the corresponding sides each in the second triangle, then the triangles are said to be congruent. So here we say that AB is equal to DE, then BC is equal to EF, and AC is equal to DF. This implies that triangle ABC is congruent to triangle DEF. This is a symbol for congruency. Second test for congruency is SAS. That means 2 sides must be equal in size and the included angle must be equal. So when we look at these triangles, ABC and PQR. So let us say that side AB is equal to side PQ and side BC is equal to side QR. The included angle between these 2 sides in each case is angle B over here and angle Q over here. So 3 things we can say is, number 1, AB is equal to PQ. Second, angle B is equal to angle Q. And third, side BC is equal to side QR. Therefore, triangle ABC is congruent to triangle PQR. And what is the congruency test in this case SAS. Any two sides are equal to the corresponding sides in the second triangle and the included angle is equal. Third test for congruency is ASA. Here it means that any two angles and the side included between the two angles should be equal to the corresponding angles and the included side in the second triangle. So we are looking at triangle PQR and LMN. Here, first thing we notice is that angle P is equal to angle L. Second, angle Q is equal to angle M. Third, if you notice that side PQ, P and Q are on two sides of this uh, of the line PQ, making angles with the other two sides. So PQ and the corresponding side is LM. So PQ is equal to LM. This implies that triangle PQR is congruent to triangle LMN. And this is by congruency condition ASA. Test AAS is an extrapolation of ASA, because if two angles of the triangles are equal, the third angle will automatically be equal. So in case I'm saying that angle A is equal to angle P and angle B is equal to angle Q, then it automatically implies that angle C is equal to angle R, because the sum of the three angles of a triangle is 180 degrees. So third angle has to be equal. Now let us say in this case side AB is equal to side PQ. So we can take angle B and C and the corresponding angles Q and R, and now the side is not included. Then also these two triangles are congruent. So I could write that angle B is equal to angle Q, angle C is equal to angle R, and third is side AB is equal to side PQ. Now this is not the included side, but still it will satisfy the same condition as we have discussed. So this also implies that triangle ABC is congruent to triangle PQR. Now we come to the final test of congruency, which is called RHS. So RHS stands for R is right angle. That means both the triangles have to have one right angle. So in this case, as we can see that angle E and angle Q, they are right angles over here. Then the hypotenuse have to be equal. So hypotenuse is the side opposite the right angle. So I can say that DF is equal to PR and any other side is also equal. So we could say that DE is equal to PQ. We could have also taken EF or QR. So first condition is that angle E is equal to angle Q, 90 degree each. Second condition is hypotenuse, that is DF is equal to PR. And third condition is that side DE is equal to PQ. This implies that triangle DEF is congruent to triangle PQR. So using any of these four tests, depending on the information available in the question, we can test whether the triangles are congruent or not.